Hey folks, welcome to my channel number 10. So there we have the problem on the screen. Y equals e to the power 3x divided by 1 plus e to the power x. Looks like we have a problem of the type u by v, which means that we will have to invoke the quotient rule of differentiation. And let's write down our u and v first before we actually get into solving this problem. So my y equals e to the power 3x divided by 1 plus e to the 1 plus e to the power x. My u is nothing but e to the power 3x, and my v equals 1 plus e to the power x, right? And we've been asked to find y dashed, and my y dashed is nothing but I'm going to apply the quotient rule here, and we know what it is. So this is my y dashed, vu dashed minus uv dashed divided by v square, right? So we know what is our u and v, and I'm going to jump to u dashed and v dashed. So let's start off with u dashed. So I'm not going to do this by the method of substitution, but I'm going to kind of go about doing this using the chain rule, but by skipping a lot of those interim steps that we normally do, right? And I want you to get used to the practice of solving such problems. You don't have to necessarily do a substitution at every stage. Like for example, if you pick up e to the power 3x, then my u dashed is d by dx of e to the power 3x, right? So again, the way to identify this is we have two functions. One is a cube function because my u is nothing but when I call it as e to the power 3x, it also means it is e to the power x the whole cube, right? So I can also write it like this, right? And let me bracket this out, folks. Right, so this is what it is. And so it is a function which has got a cube function, and then it has got an e to the power x inside the cube function, right? So how do we go about differentiating this? So I step one, I differentiate the cube function, which is my outer function, but I don't differentiate it with respect to x. I'm differentiating with respect to the inner function, right? So when my function is of the type e to the power x, the whole cube, my outer function is a cube function, my inner function is a e to the power x. When I do a differentiation of that with respect to e to the power x, then I apply the rule d by dx of x to the power n equals n times x to the power n minus 1, right? But remember, folks, we are differentiating this with respect to e to the power x and not x, right? So I have my first part of u dash as 3 times e to the power x the whole square, right? And what is that? 3 times e to the power 2x, right? So I write it as it is. And then I go about differentiating the inner function. And what is my inner function? My inner function is e to the power x, right? I'm just calling it in yellow, right? So e to the power x. And what is d by dx of e to the power x? So I first differentiate the cube function with respect to the inner function, and then I differentiate the inner function, but this time it is with respect to x, right? And what is it? It is nothing but e to the power x itself. We know this from first principles. So I have this answer for u dash, which is nothing but 3 times e to the power 3x, right? So that is my u dash. And now I come to my v dash, which is d by dx of 1 plus e to the power x, which is pretty simple. I apply some rule in differentiation, so I get an e to the power x. Right? So there we have our u dash and v dash. So I can go ahead and put it back in my y dash, right? So let's do that. My y dash is u dash minus uv dash divided by v square. So maybe I will write that out as well before we actually make the substitution. My denominator, which is v square, is nothing but 1 plus e to the power x the whole square. And then let's go to the first part of the numerator, which is vu dashed. So I have my v, which is 1 plus e to the power x. And then I have my u dashed, which we just worked out, which is 3 times e to the power 3x, right? So I 3 times e to the power 3x. And then I have my uv dashed. My u is e to the power 3x. And then my v dashed is e to the power x, right? So it looks like I can do a little more of simplification. So I express it still in terms of u by v format. So my first part becomes 3 plus 3 times e to the power x into e to the power 3x, right? So what is that? 3 times e to the power 3x plus 3 times I have e to the power 4x, right? And then I have my second part, which is nothing but e to the power 4x, right? I have an e to the power 3x into e to the power x, which is nothing but e to the power 4x. So there I have my final answer. 3 times e to the power 3x, which is I write it as it is. And the second part becomes plus 2 times e to the power 4x. So that's my final answer. I'm going to highlight it in pink. So 3 times e to the power 3x plus 2 times e to the power 4x, the whole divided by 1 plus e to the power x, the whole square. So that's the final answer for this problem. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.